Hi, this is Professor Pawan Kumar E from Department of ECE, Sai Vidya Institute of Technology. Welcome to Savi channel. Today I will be teaching you Advanced Communication Laboratory 15ECL76, which is a video curriculum. The first experiment is time division multiplexing and demultiplexing. Time division multiplexing and demultiplexing. The aim of the experiment is to design and study the working of TDM modulation and demodulation system with the help of suitable circuit. Operators required are: first one, IC CD4051, second, resistors 1.5K, 3.3K. Third one, capacitor 0.1 microfarad. So these are all the components required. Once again I'll repeat: IC CD4051, resistors 1.5K, 3.3K, capacitor 0.1 microfarad. Before proceeding to the experiment, let me introduce the theoretical part of time division multiplexing. So in short form, we call it as TDM is a method of transmitting and receiving independent signals over a common signal path by means of synchronized switchings at each end of the transmission line, so that each signals appear on the line only on a fraction of a time in a alternating patterns. TDM is used primarily for digital signals, but may be applied in analog multiplexing, in which two or more signals or a bit streams are transferred appearing simultaneously as a sub-channels in one communication channel, but are physically taking turns on the channel. Procedure of this one: first we'll consider the design part. In considering the design part, message signal M of t of 200 Hz and M1 of t of 200 Hz and M2 of t of 400 Hz. Obtain back the original signal passing through the low pass filter, considering Fc is equal to 200 Hz. So we know the formula: Fc equals 1 over 2 pi Rc. Assume C equals 0.1 microfarad. Evaluating for this, R is equal to 1 over 2 pi Fc C. So we'll get R is equal to 7.9 K. So we use a standard resistance which is equal to 5.4 K. So second, Fc is equal to 400 Hz. We know that Fc is equal to 1 over 2 pi Rc. Assume C is equal to 0.1 microfarad. Evaluating for R is equal to 1 over 2 pi Fc into C. So after performing this, we'll get R is equal to 3.9 K. So standard resistance we can use SR equals 3.3 K. So we got to know one more IC called CD4051. CD4051 features are CD405XB is analog, mux and demux. They may ask you viva question about CD4051. Second, voltage 3 volts to up to 20 volts we can provide. Third one, CDIP is a 16-pin IC. So keeping in this perspective, applications are analog and digital, mux and demux, A to D and D to A conversion, signal gating. Fourth one, factory automation. So these are all the examples or applications of CD4051. So after doing these things, we have to consider now a circuit diagram. I'll show you in the video. So this is circuit diagram. So first we'll be having two ICs, CD4051, CD4052. Here we should have pin number 13 and 14 will be the input M1 of T, M2 of T, which is connected with the signal generator, 2 VPP 200 Hz. M2 of T is connected with the 2 volts and 400 Hz. Rest of all, like 16 pin number is should be connected to 5 volts. 6 pin number, 7 pin number, 8 and 9 and 10 should be connected to ground. And after connecting individually, we can test it the pin number 3 as an output with the TDM output. So after performing this one, we have to connect one more IC CD4051 with a power supply of 5 volts to the pin number 16. 6, 7, 8, 9 and 10 are should be connected to the ground. Connecting 11 pin number of IC1 and 11 pin number of IC2 to the carrier signal C of T with a greater than 10 kilohertz. This is very important and it should be 5 VPP. After connecting, switch on the power supply and checks the results in pin number 13 and 14 before demodulation. So here after constructing with a modulation technique, we had to go for demodulation by using a low pass filter as we showed in the video. So connect a pin number 13 with a 1.5K resistor in a series with a capacitor C1.1 microfarad for retrieve back of M1 of T. In the 14 pin number, we'll be connecting one more resistor 3.3K with a capacitor of 0.1 microfarad, which will retrieve the M2 of T. So this is how you have to rig up the circuit in a springboard to get the result of time division multiplexing and demultiplexing. Thank you.